series in which we are talking about the future of security and next-generation smart connectivity systems comprising heterogeneous IoT and other types of cyber-physical systems. I'm Claudia dos Santos from Martel, and I'm here today to learn more about Assured, a Horizon 2020 project dedicated to safeguarding the operational assurance of IoT systems. With me today is Thanassis Giannetsos from UBITECH, one of the Assured project partners. Thanassis is the technical coordinator of Assured, and together with his team, he is designing new operational assurance mechanisms for these types of systems by converting them to hardware-based roots of trust. Welcome, Thanassis. I'm glad you could join us today to shed more light on Assured.
Thanks a lot, Claudia. Thank you very much for the invitation. It's an honor of also being here, having this discussion with you, and also presenting in a bit more detail of the exciting things we are doing in the project.
Perhaps we should start with an introduction of the project. So could you tell us what is the vision and mission of Assured?
Yes, as you also mentioned, the core vision, the core innovation of Assured is basically to try to enhance the security profiles of different types of heterogeneous devices, which basically they comprise the cornerstone of today's modern systems. So we're talking about small embedded devices that can be used in connected cars, in smart manufacturing, even in the context in general of smart cities. Now, the important thing and how we differentiate in Assured from other type of security mechanisms that have also been proposed in the literature is that we are not looking security as a standalone property. So we are actually trying to convert security property with other important requirements that we need to meet in this type of systems, for instance, trustworthiness, privacy, but also safety. We are talking about real-time systems that are actually working in making safety critical decisions. Consider, for instance, in connected cars, a scenario we have collision avoidance that we want to have when we are driving. So the cars are actually exchanging information, and they need to be able to do this in a secure way, but also in an efficient manner that will not compromise their ability to take decisions in a real-time manner. So this is the safety aspect. So we are actually trying to converge all these type of properties by leveraging and combining the benefits of different types of technologies, including trusted computing for operational assurance, and also blockchain for being able to have certifiable evidence on the correctness, the correct behavior, and the security of the devices. So this is the main motivation behind Assured, and this is what we were actually thinking while we were compiling the project proposal. And as we are progressing in the project, all this innovation has also been enhanced even further to be able to also see how we can combine policy recommendation for this type of requirements. So what is an efficient way to be able to identify and deploy security policy to this type of systems, which again, keep in mind, we're talking about thousands or millions of systems that they need to be able to interact with each other in order to be able to have this so-called chain of trustworthy systems.
And since Assured sits at the intersection of technologies like trusted computing, attestation, blockchain, how do all of these come together? Could you elaborate a little bit on the key technologies that the project is currently investigating?
Yes, that's a very interesting question. And again, this is something that we are actually also, taking pride, let's say, in Assured of how we are combining these state-of-the-art technologies. I have to also highlight that it is a decision of the project that we don't want to reinvent the wheel, where we can actually use existing technologies to be able to make things even better. So what we are doing in order to be able to enhance the security profile of a device is we are actually looking at the entire stack of the application that is running in the device, from the lowest level, which is basically the software that is running in the device, to also potential network interactions with other components. Hence, for the first part, the most important technology we're talking about is the trusted computing that basically tries to enhance the trustworthiness of a device. Now, the question here is, what do we mean with trustworthiness and what we mean with a trustworthy behavior of a system? This actually means that the system needs to behave the same way as it is expected without any deviation. So if a device, for instance, again, I'm taking this example in the context of connected cars. So if we're talking about a device that is responsible for managing the brakes, So you know what is the expected and trustworthy behavior. So there should not be any deviations throughout the device's life cycle, because this is an indication of risk of a potential compromise. Now, trusted computing has been out there for many, many years. So first, this was starting like at the early 2000s, but it has been only the last couple of years, or the last 5, 6 years, where there is a lot of interest in actually providing new schemes in trusted computing. Why? Because there is a consensus nowadays that we are actually moving away from centralized systems to decentralized systems. So essentially, we need to be able to convert these devices into hardware-based root of trust, into hardware-based security tokens. And the most important thing in order to be able to achieve this goal is to actually enhance these devices with trusted components. Example of trusted components you can think of is the Trusted Platform Module, the TPM. So TPM is actually a hardware-based crypto accelerator, crypto processor that provides you features like secure storage and also secure execution of various crypto primitives. Nowadays, this is considered one of the most prominent type of trusted components. For instance, any of the new generation computers and laptops, they have a TPM integrated, and the new version, for instance, of Windows operating system, they cannot operate if they are not supported also by the TPM. TPM is also the trusted component that Azure is adopting. So all of its solutions is based on the integration of a TPM. Of course, because we want to keep the schemes as agnostic as possible, they can actually operate on different types of trust components. For instance, there is also a software-based trust execution environments from LSTX. There is also the UBITECH trust components. It's another version of a hardware-based root of trust. Now, this is the cornerstone, let's say in Azure, of trust computing, of how to convert a device into a hardware-based root of trust. Now, based on this, other core technologies, we are also introducing the use of blockchains for being able to efficiently deploy policies and to be able to actually keep in a certifiable manner all the evidence regarding the state of a device. So in Azure, we are basically interested in runtime operational assurance. So how the correct state, how the assurances change throughout the life cycle of a device. And in order to be able to have this type of auditing and to be able to transact and record all of the evidence, this is where we're actually using the blockchain. So both for keeping all of the state information from a device, but a new feature, which is also one of the innovations of Azure, is that we are using the blockchain as the policy decision point. So this is where basically we are pushing security policies, and all of registered devices, they can actually get the policies from the blockchain in a secure way, execute the policies, and then actually push back in the ledger, in the blockchain, all the results. And of course, based against this, all of the information is stored on the ledger. This provides the market as a hygiene market, let's say. So this is the data, all of the data sharing with external stakeholders or with system administrators takes place in an authenticated way through the blockchain. So this is the second pillar through the integration of blockchain infrastructures and distributed ledger technology. The third pillar is also risk assessment. So we are leveraging the latest trend when it comes to the risk methodology, which is the CVSS 3.1. And this was actually proposed by ENISA, the Standardization Working Group, last June. And we are actually using this methodology, and we are creating a risk assessment framework in the context of the project that will first identify all possible vulnerabilities for all of the assets of an ecosystem, of an application domain, be it software assets or hardware assets. And based on these vulnerabilities, it will interact with the policy recommendation engine to identify what are the most appropriate and optimized security policies to be deployed. And this is the fourth pillar. So by combining these four technologies, we are actually able to withstand even the most advanced type of software-based attacks that try to manipulate the system in a way that essentially goes unnoticed.
And looking at the Azure team, it becomes clear that diversity is one of the strengths of this project. So could you tell us more about the expertise of the different partners involved?
Yes, of course. So we are actually very lucky that we constructed a very, very strong consortium during the proposal preparation phase, where we managed to collect worldwide expertise in their fields. So this actually includes both academic partners, research partners, but also industrial partners. And again, these are the pioneers in their respective fields that we're actually also using in Azure. For example, in the context of trusted computing, and especially operational assurance and attestation mechanisms, where Azure is very active in designing new schemes, we actually have University of Darmstadt in Germany, and University of Darmstadt was the first one back in 2017 that introduced the concept of control flow attestation. This is one of the main assurance mechanisms that actually Azure is also using and is providing new schemes. Also in the same field, we have University of Surrey from the UK that has a lot of crypto expertise that we are using for securing further all of our schemes. Keep in mind that irrespectively of what type of schemes we're actually creating, the cornerstone of what everyone is trusting is the cryptography, is the crypto. So we are also creating new, more efficient type of crypto primitives that we can use in this type of systems. So we have like a wide gamut of academic partners, but also industrial partners. For instance, we have NVIDIA, which creates a lot of products with very strong software-based mechanisms for how to trace the behavior of the system. And besides the technical partners, we also have very strong use case partners. So we are also likely to be able to have a variety of application domains where Azure can have an impact. So we have partners from Ireland, we also have partners from Germany, and a wide gamut of all use cases, starting from again smart manufacturing to even secure aerospace. So we are very lucky about this, and this has actually allowed us to be able, in the first part of the project, to have all of our scheme published in very well-known first-tier conference and journals, which basically this speaks to the quality of the work that is being done by all of the partners, and hopefully the quality of the implementation also that will happen at the end of the project that will further enhance the security within Europe.
Okay. And what use cases and application domains, in your opinion, will have the greatest impact?
So in the context of the project, as I previously mentioned, we are considering 4 use cases. So the first use case, it's supported by one of our partners, BIBA from Germany, which they are active in the context and domain of smart manufacturing. So this use case is about human-robot safe collaboration. So think of a manufacturing environment where you are having a number of devices, a number of robots that they are actually operating in an automated manner to be able to perform an action. And you are also having the workers moving around this manufacturing floor. So what BIBA is doing is actually they have created location positioning schemes to be able to identify from the robot standpoint and estimate the location of the workers. And if a worker is actually getting close to a robot, the robot will go to a fail stop in order to be able to avoid any accident. So you can see here the safety critical nature of such a scenario, because they need the devices to be able to have very strong guarantees that they're operating correctly, because otherwise, if an accident happens, this can actually be fatal for the worker. And this is where we are integrating the assurance schemes from Azure to be actually used in the robot of an actual manufacturing floor. Another use case that we are actually considering is also in the context of secure aerospace, as I mentioned. So we have a research partner with RCI from Ireland that is leading this use case. And this is where essentially we're talking about remote maintenance that needs to be done to each commercial airplane once they have landed. Currently, there is always the assumption that there is a worker manually going to the airplane to be able to plug in the system, get all of the data, and then be able to actually do the maintenance. So in Azure, we're envisioning that this needs to take place in a complete remote way, but at the same time, in a secure way, because again, we're talking about the safety critical component as an airplane. The third use case, which is in the same field as the secure space, we are also having a partner, Space from Greece, which they are active, they're engaging into secure satellites. So this is where basically we have access to the most prominent type of software system, of operating system, which is the CubeSat used in smart satellites. And this is where we are essentially want to further enhance the security profile of such an operating system by adding secure key management procedures. Last one, we also have in the context of smart cities and public safety. So we are lucky that we have managed to secure the participation of DAEM partner within Greece. So DAEM is actually managing a very big complex in the center of Athens as part of the public administration. And in the context of public safety, they have deployed a number of cameras, sensors that they are able to actually monitor movement of terrorists or like movement of potentially harmful substances. And of course, as you can understand, there, not only we need to have very strong security guarantees, at the same time, we also need to be able to have very strong privacy features, because we are talking about potentially the cameras also monitoring the movement of individuals. And Assured, as we mentioned, also takes care of providing new type of crypto mechanisms for enhancing the privacy profiles of users. So these are the 4 use cases that we are actually checking in the context of the project. But as you can understand, the common denominator in all of these domains, it's basically the safety critical nature of all of the applications and the devices that participate in such systems, which basically this means that even beyond these domains, and I have mentioned multiple times about the domain of connected cars and autonomous driving. This is something that a lot of partners already in Assured, they are active and they are performing research on how to be able to integrate Assured in this type also of services. So in general, any type of IoT, Internet of Things, system of system that we are having nowadays as part of the next generation networks will greatly benefit by the work that is being done in the context of Assured.
So are there any strategic exploitation avenues that Assured is targeting for these produced solutions?
So when it comes to exploitation, of course, one important thing that we are aiming for as a consortium is to be able to also exploit all of our schemes in terms of standardization. So we actually want to come into play and interact with a number of standardization working groups to be able to get their opinion, get their feedback, but also push these new assurance mechanisms as potentially new standardized ways of security, of biosecurity mechanisms. So in this direction, Assured has actually taken already a number of significant steps. So the project is already interacting with Trust Computing Group, TCG. So TCG is the main standardization working group in the context of trust computing. And they're the ones that ratify and corroborate on the validity of new type of crypto schemes and attestation mechanisms that are based on the use of TPM, a trust component, or other types of trust components. Also, in the context of the blockchains, Assured has established a liaison with ISO TC307. So this is the main standardization working group that focuses on how to use blockchain for enhancing security, privacy, and also identity management. And last but not least, again, in the context of ISO, there are a number of smaller working groups that are actually focusing on identifying new type of crypto primitives for the secure on-chain interaction with the blockchain, and Assured also is active in this. And as an example, you can consider that one of the new attestation schemes that were proposed in the context of Assured revealed a bug that was identified in the software stack for communicating with TPM. And this was actually resolved together with TCG, and this has already been published as one of the of the solutions in the TCG GitHub that contains the entire software. So this is one exploitation that Assured is pretty active and will actually become even more active in the second part of the project, where we have now all of our artifacts already designed, and we are actually going to the second phase with implementation and evaluation. Other possible exploitation is again through our industrial partners, and to be able to make sure that part of our designs can actually be pushed and tested, hopefully in real products. So for instance, NVIDIA, they are having their own routers and their own types of small embedded systems that they could actually try to integrate part of the software-based testing mechanisms that they are creating in the context of the project. This, of course, will be driven by each one of the industrial partners on their own, but we're actually keeping monitor of this type of possible exploitation opportunities from all of the industrial and use case partners. And of course, last but not least, all of us, we are researchers, so we are trying to have all of our work as open source, and that's why we are publishing all of our schemes in papers to reach out as much of the community as possible. And we are also open to anyone for further collaboration if they are interested in actually trying to test our schemes in different types of products and services.
Wonderful. As we're wrapping up, is there anything else you wish to add about the Assured?
So one thing is basically, keep following us. We are now entering the second, and this is the most, let's say, fascinating part of the project, because now it's not simply designing new schemes that we did in the first part, but it's actually testing them and integrating them in the context of our use cases and see how they operate. So think of it as that now we're going from the theoretical world to the actual practical world, hands-on, to see how all these things can materialize in what we had envisioned at the beginning. So in the next couple of months, we're expecting to have a great deal of new results that we will be able to share with the community and to be able to present into various conferences and events. And it will also be interesting to be able to get the feedback and comments from everyone that are actually also active in this type of research.
Thank you, Thanassis. This has been really interesting. I hope our audience will also find it useful.
Thank you very much for having me.